Hey everyone, this is about solving systems of equations by graphing. All right, so for a system of equation, the solutions are the intersections. So let's talk about how many we could have. If we had systems that were just of two linear equations, so just two lines, we have three different possible outcomes. Those two lines might only hit once and have one intersection, which means that they would have one solution. The two lines could be parallel, and then you would have no solution because these things are never going to intersect with each other. Or the two lines might actually end up being the exact same line, and if they're sitting on top of each other, we would have infinitely many solutions. If you have a system of a linear and a quadratic, we have these possible. Either they're going to intersect twice and we'll have two solutions. They'll just hit once and we'll have one solution. That'll always hit the vertex. Or they will never intersect and we'll have no solutions. All right, let's find the solution to the system by graphing. The first thing that we want to do is make sure that these things are set equal to y. So in this first equation, this would be y equals negative 4x plus 8. And the second equation, we got to do a little bit more work. We'd start by subtracting 2x from each side, and then go through and divide each of these by negative 3. That would leave me with y equals negative 2/3 x minus 6. So now I'm going to graph y equals negative 4x plus 8 and 2/3 x minus 6. Here it's important to remember that these are of the form y equals mx plus b, where m is the slope and b is the y-intercept. All right, so starting with negative 4x plus 8, I'm going to plot its y-intercept at 8, and then that slope of negative 4 means I'm going to count down 4 and over 1, over and over and over. Down 4 over 1, down 4 over 1, down 4 over 1. I'm going to connect these. And then 2/3 x minus 6, I'm going to start at negative 6, and I'm going to go up 2 over 3, up 2 over 3. Hit the wrong dot there. And connect these. Now we can see that we have an intersection here at 3, negative 4. So the solution to this system is 3, negative 4. Now if we're using technology like a calculator, we would solve both equations for y just like we did. We're going to graph, and we find the intersection using second trace intersect. So let me show you how to do that in the calculator. All right, so here you can see I've already typed these functions into y equals. So now I'm going to graph them, and I can see their intersection. Looks a lot like the one that we just drew. I'm going to hit second trace, and number 5 is intersect. Now here it says first curve. We just want to make sure that the spider's sitting on one of the lines. Hit enter. Now it's going to jump to the other line. For second curve, hit enter. On guess, hit enter again, and the intersection is at 3, negative 4. Just like what we saw whenever we graphed it ourselves. Okay, so one of the special types is systems with infinite solutions. So whenever these things are solved for y, they're the exact same equation, so they're just lying right on top of each other. We can see this if we just solve each equation for y. In the first equation, we subtract 4x and then go through and divide by negative 3, giving me 4/3 x minus 8 over 3. The second equation, negative 6y is equal to negative 8x plus 16. And after dividing each of these things by negative 6 and reducing, we again get 4/3 x minus 8/3. Because these things are exactly the same, their graphs are going to lie right on top of each other, and we'll have infinitely many solutions. Systems with no solutions are parallel. And parallel lines have the same slope but different y-intercepts. So we can see this one's already solved for y. If I solve this other equation for y, I get y equals negative 2x plus 1. So these have the same slope of negative 2, but different y-intercepts. And here you can clearly see on the graph that these two lines are never going to intersect. All right, so now let's try a system with a quadratic, but let's do this one using technology and find the solutions. All right, so both of the equations were already solved for y equals, so I can go ahead and type those in and graph. Now whenever I'm looking at this, I can see that this is going to have two solutions. So I'm going to have to do my second trace intersect twice. So first curve, second curve, guess. One of my solutions is at 1, 4. And then whenever I do this again, this time whenever I do my second trace, the intersection, I want to move these spiders a little bit closer to the other intersection. So first curve, second curve, guess, and that shows me that's at 4, 1. And now I've got both solutions. All right, and that's systems of equations by graphing. Goodbye.